In this section of notes, we're looking at the idea of a sampling distribution for a difference in proportions. So what we've got is we've got two different populations that have two different, I guess technically they could be the same, but they've each got a population parameter. And then you're going to take a sample and you're going to get a statistic, and you have a sample size for that sample. So this is kind of the information that we have. So here's kind of an example to look at. We've got two different schools. At school number 1, we know that 70% of students did their homework last night, and school number 2, we know that 50% of them did their homework last night. So we're going to take two samples. We're going to take a sample of size 100 from school 1 and a sample of size 200 from school 2. And we want to look at what would the sampling distribution for the difference of those samples look like. So in these three graphs, the graph furthest to the left, that is our sampling distribution for school number 1. You can see that we've got the center at 0.7, and we've got our formula from a previous section of notes where we were able to find the standard deviation of a sampling distribution. Same thing in the middle, that's your second school. And using what we know from chapter 6 about combining random variables, we know that to find our new mean, we just subtract our two old means, but it's a little more complicated for standard deviation. Remember that for standard deviation, you don't just add or subtract, you have to go back to variances, and variances always add. So here's kind of our formulas from back in chapter 6. So we know that in terms of shape, we need to check both shapes, and we need both of them to be approximately normal. In our last section of notes, we learned about the large counts condition. So we need to check the large counts condition for both populations, and if they both work, then that means our sampling distribution of their differences will also be normally distributed. For the centers, we know that we're going to take the difference of the two population centers, and that should be the center of our sampling distribution. And again, for spread, we have to find the variances, add the variances, and then take the square root of that to turn it back into a standard deviation. Don't forget that those formulas for standard deviation only work if you are drawing with replacement, which we pretty much never do, or if your sample size is less than 10% of the population size, so it meets that 10% condition. So if we look at our example that we started with, where we've got our two schools, we've got our two p-values, and our two sampling sizes, and we want to come up with the shape, center, and variability for the difference in proportions. So we check our sample size times our probability of success for both, and they both need to be greater than or equal to 10, and we do that twice. So here are number of successes and number of failures for school number 1, they're both bigger than 10, and then our number of successes and our number of failures at school number 2, they're both bigger than 10. So both of those are bigger than 10. That means that our sampling distribution for the difference in proportions will both be normally distributed, or approximately normally distributed. We've got our formula for our means, where we just subtract the two means. And again, be a little careful. We have to take our variances, add them, and then take the square root to get our standard deviation. Make sure you take a few moments to try the practice problems for this section before moving on.